All right. Good morning. Let's try again. Good morning. Thank you. Thank you so much. I know there are lots of conference sessions running in parallel. Thank you very much for choosing my session. I'm honored that you decided to come to my session. Hopefully, I will make it worthwhile the next 50 minutes where you will learn a few things and I will learn a lot more from you as well. My name is Arun Gupta. I work for Red Hat. And today we're here to talk about DevOps with Java EE. All right. I run the developer outreach efforts for Red Hat for all of middleware, whether it's technical marketing, which is product oriented, or as community outreach, or talking to people like you, developer advocacy. So I run that team at Red Hat. Lots of different ways to reach me. I got a Twitter handle like anybody. I blog pretty excessively. I'm a compulsive blogger. I go to blog once or twice a week. I don't feel very happy otherwise. And then you can shoot me a mail at arungupta@redhat.com. So my goal is, at the end of the presentation, to show you exactly how to build a deployment pipeline like this with Java EE environment. Okay, this is an animation because I just put the slide in there, but at least you know what we are leading to. So hopefully by the end of the presentation, you'll be able to see how to build this entire pipeline with literally push to prod, for your setup. Now, it's a very classic problem. You do testing in your machine, you have an environment, you build your application, works fine, you test for 5 users, 10 concurrent users, and you throw your code over the wall, it goes to the ops sides, and it's on fire. The ops guys are running around, and I'm sure we have all gone through this. I've gone through this multiple times. Oh, my code is fine, it's your problem, your setup is all messy. I think that's the classic problem we are trying to solve by this DevOps. So is DevOps for you? Well, there are lots of surveys that are being done around. This particular one was done by Puppet Labs, and it shows that if you are using DevOps technologies, DevOps methodology, then you can ship code 30 times faster. Sounds pretty cool. It has a lot less failure rate, so 50% less failures. So that's pretty cool. That's a pretty promising option. Now, the organizations that are implementing DevOps, they are doing better deployment quality, faster release cadence, and a lot more improved process visibility. Effectively, if you have process visibility, the other two things automatically comes in handy because then you're more aware of what the other party is responsible for or what they're going to do. On the right, what you see is a box from Amazon where they're doing 10,000 deployments per hour. On a scale of Amazon and doing 10,000 deployments per hour, think about the complications. Think about anything and everything can possibly go wrong in that time frame. But they're using DevOps. Mean time between deployments is about 11.6 seconds, and a failure because of a software error is literally 0.001%. Hardware, yes, but because of software, primarily, there are no issues, very minimal issues. Okay, so what is really DevOps? Well, back in the old days, we used to do, build. There were this fine craftsmen who would work in a workshop. They will spend days, maybe months, maybe years, building a very fine piece of artifact, and then it would be available. Now these days we are very impatient. I just want to get the thing now. Before it's conceived, I just run a Kickstarter. I want to have the thing in my hand. So that's basically the concept that we are adopting in the IT industry as well. This concept has been available for many, many years. It's just that IT is a little laggard in that sense. We're trying to understand, oh, they've been doing this, let's try to apply those methodologies to IT as well. So effectively, you bring manufacturing concepts, all those terminology to IT, which is called as DevOps, and the factory that they had, what we call as cloud. So DevOps and cloud kind of run hand in hand. We're very, very useful concepts together. So, depending upon who you ask, everybody has a different definition of DevOps. Depending upon whether you're sitting on a tail or a leg or a trunk or a body, they all have different definitions. But to me, really, I go back to what Jez Hempel has said. Jez Hempel is the author of the book called Continuous Delivery. Excellent book, actually, if you haven't read it. And he has called it, manifesto is a little bit of an evil term, but he has written called as a DevOps manifesto. He has described what DevOps really means. To me, really, it's a lot of bullets, but the key points that really highlights the summary of DevOps is it's really a reaction to poor communication between the dev and the ops. Dev start their efforts, 95% done, they throw the code over to ops, then ops are living in their own silo. So the idea is to bridge that gap between the silo and have a much more improved visible communication. Because of that communication, the visibility is much higher. As I said, that is really the key part here. The dev and the ops are working together to achieve the entire functionality. And I'll talk about what do you mean by working together. Automation over documentation. Don't believe in readmes. Don't believe in, oh, so-and-so developer needs to run this script in order to get this deployment running. No, we humans are always horrible in terms of making errors. We always make errors. That's how humans are. So let's leverage computers for that. They're dumb, but they're really good and repetitive tasks. Another one is, how do you create a self-service infrastructure for teams where if anybody wants to push their feature out in production, they don't have to rely upon 5 different approvals and 3 different people to provision a machine. That's where cloud comes in very handy. And last but not the least, if you build a project, it's not done until it's retired from production, until it's done. So that's sort of the essence that, if you know that once you have built a project or a product and it's live and you could get a call 3 in the morning, you will make sure that the product is solid. So what are the key components of DevOps in that case? Well, people, process, and tools. That's how I typically see things. And in terms of people, really dev, which is the developers. And I'll talk about how do I classify them, developers and ops people. In terms of processes, continuous delivery is really the primary process that we're going to talk about, which basically we lead to. Agile methodologies come as part of that. And in terms of tools, there are lots of tools. Everybody has their own recipe, but the common ones that I've seen across my discussions with developers and customers and partners is Jenkins, Chef, Sonar, Arquillian, Paas. All those are some of the tools that I've seen people using. So how do I classify DevOps? Well, I call them as 5 C's of DevOps. The first one being collaboration, which is, again, a very, very important part of it. Collaboration between developer and operations. Culture. Culture is the most fundamental and the most blocking factor for implementing DevOps in your organization. We'll talk about that. Code, everything. Not just the Java source code or your Python script or your shell script. Everything. And we'll talk about what that everything is. Because you code everything, it gives you a consistency, how you can automate everything, which gives you the repeatability, how you can get the same result again and again and again and again. And last but not the least, continuous delivery. So this is what I call as the 5 C's of DevOps. So let's kind of dig deeper into each of the C and see what does it really mean. So when I talk about dev, I really talk about engineering, anybody who's responsible for the development of the product, whether it's the product management, product marketing, well, product marketing doesn't do development, product management, engineers, engineering managers, testers, QA, all of those come in the dev part of it. Typically, lead engineer will go do the requirement analysis with product management, and then the development will happen all the way to the end. 90%, 95% done, you throw the product over to ops, say, let's go production. And ops on that side is anything to do with your infrastructure. So system administrators, DBAs, network infrastructure providers, all of those guys. This could be within your company, outside your company. It really doesn't matter. There are no boundaries to that. But essentially, a very, very critical component of all of that is a very close collaboration. Literally from the project requirement phase, when the project is conceived, the dev and the ops have to work together. That, all right, this is sort of the end goal. We're both responsible for that end goal. Let's work on it together. Start right from there itself. Now, devs, as a developer, we think, I want to live on the bleeding edge. Always want to put the latest feature out on the website. And ops thinks, you just moron, you just live on the bleeding edge. I just want to keep the site stable and fast, make sure it's accessible. That's sort of the old school of thought. So, ops job, by the way, is not to keep the site stable and fast. That's very, very important to understand. Their job is to enable business. Because end of the day, if the business is not running, everybody suffers. And so in that sense, dev's job is also to enable business. So that right balance between bleeding edge features and getting the business enabled and getting the site stable and fast is exactly what they need to achieve. So I see really DevOps as a marriage, call it a happy marriage, maybe an oxymoron for some, but it has to be a happy marriage that works in tandem. They both have to work with each other very closely to make sure it's a smooth sailing ride. Culture. This is the most difficult part of implementing DevOps in the organization. Very, very fundamental points, but human fundamental points, but again, very, very difficult to achieve. You have to respect each other's expertise and opinions. When a dev tells an ops person that, you know what, the kind of infrastructure you're setting up is not going to scale for our needs, you got to understand that, listen to that. But similarly, when the ops says, hey, when you write this kind of a code, and this kind of a code was problematic in our ops like 2 years ago, understand to that ops opinion. So it's very, very important to understand each other's perspective. So put yourself in the ops shoes, similarly, vice versa as well. So effectively, you need to trust each other, and think like the other person and see how that can achieve. Overall, that leads to transparency because, from day one, as I said, from the requirement phase, you're working hand in hand to make sure the requirements are very clear from the beginning, that we are defining a project, that project requirement is 10,000 concurrent users. 10,000 concurrent users means, so and so hardware requirements, and I want cloud bursting, and during Thanksgiving time, it will be maybe 30,000 customers. How are we going to scale? So everybody kind of builds a joint plan together. And really, I mean dev and ops together. And that's very important. Like at any point of time, shit hits the fan. What do? You turn off the fan first. So you build a joint recovery plan. You don't start pointing fingers at everybody that, no, your problem. You again work towards it to build a joint recovery plan. And as a process, you amplify the feedback loops early in the cycle. So if there are any issues that you think that ops are not responding or devs are not responding, you amplify the feedback loop in sort of the joint scrum meetings or whatever they are. This is a beautiful drawing. I like it. How DevOps is done at Flickr. So typically, when an issue is identified, you say, "Oh, damn it! There's an issue now." So you start freaking out. You don't talk to anybody. There are silos in the hallway. To anybody, you are eventually pointing fingers at everybody. Lots of whining. Lots of hurt egos, meetings, all that stuff. And then finally, it's business. So you go to solve the problem. So you solve it, fixed. All right, next problem. And this cycle repeats on and on. So instead of finger pointiness, Flickr adopts this example of being productive. Find out a problem identified, you figure it out, you fix it, and then you feel guilty and the life moves on, basically. So imagine how many of you, think about how many of you are in the first category, how many of you are in the second category. Second category is what is a lot more productive because effectively you're not wasting time on that finger pointiness and finding who to fire effectively. One of my ex-managers, she told me, and I really took it to my heart, treat people warmly, issues coldly. Unfortunately, what happens is the other way around. He says, damn it, this is my issue. How dare you file a bug on this? Now, it's an issue, right? It's a valid issue. If it's not a valid issue, don't close it because some junior developer filed it, say, cannot reproduce or won't fix or things like that. Just look at the issue, beat the issue to death, because eventually both of your responsibility is to bring a higher quality of the product. Uncle Ben, and I love this quote from him. He says, with great power comes great responsibility. So effectively, going back to one of the DevOps manifesto points where I was saying, if you build it, you run it. The fact that you could get a call 3 a.m. in the morning if your product feature is broken, not the ops guy, you will make sure that you have done all sorts of due testing. Now in Netflix, there is a capability that any developer can push any feature at any point of time. And Netflix runs on Amazon. Thousands of servers on Amazon across 3 different geographies. They have the capability, they have a self-service infrastructure where they can say, oh, provision this particular feature on 10,000 nodes across this and this geography. They can do that. They have the capability. Great power, but full responsibility. If the feature goes down, the developer has to wake up because it gets an alert that they have to wake up and fix it. Fall back, canary release, and all those kind of things have to be done. So I think it's very, very important to understand with DevOps, the whole concept of you build it, you run it is essential. Now, I talked about code everything. So typically, you start with application source code. That's, of course, what we require. But really, it shouldn't stop there. You don't want to type your build command with the 500 jar files in the class path. Shell scripts, common. Maven, still very, very common. But that's where most of the people stop. Everything kind of goes in a README, which the ops team is going to do. Oh, no, they're going to reproduce that entire environment in the ops, and that's how it's going to work. But really, I'm talking about database schema, configuration files, test data, DDL, DML, provisioning scripts, monitoring scripts. And who really needs scripts these days? Just write a Docker file and say, what, everything is documented in there. Pull everything from a S3 bucket or pull everything from a GitHub repo, and everything should really be documented. And I pretty heavily use Docker for all my daily things in that sense. So I think that really gives you the reproducibility. So everything is really, coded for me in that sense. And that's where, I love the code by Agent Smith. Never send a human to do a machine's job. Because a human, as I said earlier, is bound to make an error. It's very, very likely. We have sentiments, we have feelings. We eat breakfast. If we don't eat breakfast, then we don't operate properly. With machines, that's not the case. All they need is that dumb power. Once the power is on, you tell them to do a job, they just keep doing that very nicely. They don't have feelings. Oh, I've done this job 100 times. I'm not going to do it anymore. Humans do that. Machines don't. They're very good at repetitive, boring tasks. Leverage them for that. Consistency. Well, consistency comes from the fact that you automate everything as opposed to documentation. You don't want to give a Java EE war file to your ops and say, oh, by the way, when you deploy this war file, here are 7 instructions you need to follow. Create this JDBC resource, create this JMS resource, blah, blah, blah. No, that's very confusing. Somebody will make an error. Or don't say run this script or do that. No, it got to be automation, completely automated. You give a war file, add the deployment type, the resources should get created, and all those things should happen automatically. Figure out a hook, figure out some mechanism by which everything is automated. And that really gives you repeatability, because if it's automated, you can run that same thing again and again and again and again from dev to test to prod, dev to test to prod, whether it's a tag, whether it's a Nexus repository, wherever it is, it gives you complete repeatability of your environment. And effectively, that leads to your push button deployments that you say, okay, git push with that, and everything just triggers in a cycle. And we'll talk about the deployment pipeline in a second. And it just goes to the deployment. You go to manage your environments. We'll talk about environments in a second. But effectively, with automation over documentation, you don't fail your crash test. You don't want to be a DOA or dead on arrival, that the moment the product is launched, boom, you didn't anticipate that need, and the product is dead right away. So that's not good. Now, you may think automation over documentation is good, but some people may call you as complainer or lazy or quitter and things like that. So I think this Dilbert cartoon really summarizes it for me. You automate a task, and then somebody says, oh, you are lazy. No, I'm not lazy. I'm just being efficient. Yeah, if I get that task automated, then I can move on to better things as well in that sense. Now, what do I see in terms of managing environments? Well, lots of different environments you need to manage. So not just your IDE or your operating system or your JDK or your database. Lots of different things. Cloud is a very, very important concept here, specifically in terms of DevOps. How you can leverage, your VMs or your Docker containers, Paas environments very well, in terms of cloud. What kind of virtualization are you using? Are you using a VirtualBox? Are you using VMware? Are you using Vagrant? What those environments are, and they all together kind of give you some sort of reproducibility. Containers. As I said, I use Docker pretty heavily for all of my daily things. App servers, of course, JBus EAP is our preferred choice from Red Hat. Configuration tools. You have Puppet, Chef, Ansible, Salt, a whole variety of tools that are available. How do you orchestrate your containers? Are you using Kubernetes? Are you using Swarm? Are you using a combination of Kubernetes and Mesos? So all of these different environments you got to manage. And again, remember, you got to code all of them. You got to put them in a Git repo or somewhere where it's 100% reproducible. Dashboards, is a very, very important concept of how do you build transparency. So I particularly love this dashboard. This is a Stack Exchange dashboard. If you go to the URL, then you can take a look at it, how the dashboard is so fancy. It literally talks about how many web servers, how many SQL servers, how many pages, what is the average response time, and things like that. So at any given point of time, any of their team members can look at the infrastructure and say, you know what, this particular web server is not behaving well, and you can click on it and then get more details about that particular web server. So you can add more web servers, or say, you know what, there are 9 web servers, only 2 are being used. Now 7 are sitting idle for a while. So let me pull out some web servers and utilize them somewhere else. So I think that overall builds transparency for everybody. The last C of DevOps, as I say, is called as continuous delivery. That's sort of where you want to lead to. Now, continuous delivery means you build, you deploy, you test, and lots of automated tests, but then in some manual tests, and finally a release. Okay, that's sort of the whole concept of continuous delivery. Continuous integration, of course, is a basic requirement for continuous delivery. Typically, in the conferences that I've spoken at the developers I'm talked to, I would say 80% are doing continuous integration, and the definition or the maturity of continuous integration is very different. I mean, in terms of continuous integration, is really all it is. You check in a source code, there's a build machine, which Jenkins, Travis, something is running, which checks out your source code, builds it. That's it. There's no requirement for testing. It just makes sure that the workspace is buildable. A lot of people do that. Then people add flavors to it. Oh, I'm going to run tests, unit tests, functional tests, integration tests. And that's where the fun starts. How advanced you are, how mature you are in your CI cycle for that. Continuous delivery really gives you the ability, because you are constantly getting, remember we talked about amplify feedback. It gives you constant feedback. So you fail fast and you recover that way, and which is the right way to do things, instead of waiting for 3 months to figure out where the error was and then figuring it out and fixing it and then failing big time. Self-service provisioning environment is very, very important. 100% automation is a key part. Continuous delivery effectively gives you push to prod. So as soon as push, all that cycle completely automated, and I'll tell you how we achieve that continuous delivery over there. Proactive monitoring and metrics is very important. That if you're running those automated tests, if you're running code quality, if you're running performance tests, if you're running regression tests, if you're running longevity tests, all sorts of tests are being run. You need to have a mechanism by which you identify when do I hit the threshold and I'm failing and I need to take a corrective action. So this is a beautiful book by Jez Humble and David Farley. I've read it a couple of times. I just enjoy every time I read it, and I pick up a few nuggets from it. But effectively, continuous delivery is the practice of releasing every good build to your users. Every push that you make, you define what a good build looks like. Okay, it's passed 90% of the tests, or there are no regressions, whatever your criteria is. But once you have met that criteria, every push to your workspace is effectively a release candidate. That's how you want to think about it. And CI is a basic requirement, or continuous integration is a basic requirement, but effectively is taking continuous integration to its logical conclusion. Because you're not just doing CI for the sake of CI. You effectively want to convert that build into a release candidate, and continuous delivery allows you to do that. Now, the way you do continuous delivery is by creating a deployment pipeline. And what is a deployment pipeline? Yeah, well, deployment pipeline, again, as I've been talking about it, automation over documentation, 100% automation, is an automated implementation of your complete devs, prod, test cycle, all of that. Okay, so let's take a look at that. Well, before that, within Red Hat, we prepared something what we call as a continuous delivery maturity matrix. At the top, what you see are 5 columns. These are CMMI, Carnegie Mellon CMMI levels: initial, manage, define, quantitatively manage, and optimizing. When you look on the left side, which is initial, which is the very first column, or the second column rather, it says sort of where is the basic phase. Your goal from left side of the matrix to the right side of the matrix as you mature yourself. And then there are different rows which talks about, like, okay, in terms of culture, or in terms of release, or in terms of test and verification, where do I sit? As I said, let's say you are doing some unit tests, some separate test environment, you are at the initial level. Then you look at what does it take for me to get to the managed environment. And then you will start working towards it. And that's how you want to move. There are probably very few organizations that are rightly in the optimizing column at all levels. So you want to take this matrix, put this in your dashboard somewhere, and say, where do I fit in the matrix? And define a goal that I want to move towards the rightmost column. In terms of tools, so we talk about people, processes, and tools. The third thing in terms of tools, for CI, there are lots of tools. Jenkins is the most popular one. That's the one that I'm most familiar with. I'm very, very proud to say that when we started Project Hudson back in the Sun days, and my history goes back to Sun, Kosuke Kawaguchi and me were in the same team. And we used to scavenge around the hallways of Sun, looking for machines and putting them as Hudson clusters and Hudson slaves. That's how the Project Hudson was started. Because of some history, the project got converted to Jenkins. I have a close attachment and a personal attachment to Jenkins. That's what I end up using all the time. In terms of versioning, Git is the prominent tool here. SP and Mercurial, bunch of other tools as well. Lots of tool for monitoring as well I've seen people using. Logging is again a very critical part of it. So let me give you an example of Netflix, an organization which is doing DevOps pretty effectively. They do up to 1,000 releases a day. There is no separate team which is a DevOps team. If you see there is a DevOps engineer, or if you see there is a DevOps team, just run away from it. That organization doesn't get it. There should not be a DevOps manager or a DevOps team. DevOps means really Dev and Ops, same set of people working together. That's really the key part. At Netflix, as I said, they are running 100% on Amazon. Their 70% instances on Amazon changes in 2 weeks and 90% every month. They recycle images so effectively. And how that's possible? By 100% automation, by managing their environments. And that's how they do. There is no Java EE here, but just to give you an idea how organizations which are very effective in DevOps, they are doing it. Fully automated, 100% automated, really. There is no question about it. On a Friday night or a Saturday night, 33% of traffic in the US is Netflix traffic. I know in my house, 100% of traffic is Netflix. We probably have 3 devices and all operating 3 different movies at a given point of time. Another wonderful example of DevOps is when Barack Obama won the campaign for US presidency in 2012, their team, again, Scott Vendenplast, he ran his entire IT operations, and he tweeted about this, how they started building a data center ground up. 83 days, they started ground up, took it all the way to the peak, and then they dismantled it, everything running on Amazon. So it's pretty cool as well. So you can see the kind of tool sets that they use over there. So these are a couple of examples which are out the prominence, who are using DevOps pretty effectively. Well, our talk is about how do you do DevOps with Java EE. So this is sort of the tool set that I'm going to show today. Again, this is just one tool set that I have picked, which seem to work effectively, and I have a recipe for that. You're by all means free. The story that I'm going to share with you today, by all means free to take out a piece and plug your own piece. But effectively, what I'm doing is I'm using a WildFly or JBoss EAP as my application server, which is a Java EE application server. Using JBoss tools, which is Eclipse with a bunch of JBoss plugins for doing your Java EE development. Using Nexus as my Maven repository, Git as my source code, using Sonar for static code checking. I'm using OpenShift for all my images where my deployment is going to happen, for my build is going to happen, testing is going to happen. Using Maven as my build tool, Jenkins is my CI server, and Arquillian for testing. So these are sort of the basic components that are part of my deployment pipeline here. So let's go back to the image that I showed in the very beginning of the session itself. Well, here we go. Now, I have my development environment on this machine where I'm presenting from. I have WildFly, JBoss tools, Maven, Git. That's very common. That's very normal. Pretty much all the people that do Java EE development will have some sort of that environment. So I have that environment. Now, there's a Git repository, not necessarily GitHub, but some Git repository. You clone a workspace from there, you make changes, you push the changes to the Git repository. Now, that's cool, but you need a CI. So that's your basic requirement, as I said, to build your deployment pipeline. So once, and on a CI, which is Jenkins server, you have Git install, there's Jenkins running over there. There is a hook that you have configured that every time I do a Git push, CI is going to check out the workspace and it's going to build it. Well, where do I build it? So what I do say is, hey, you know what? Go provision instance somewhere. Maybe OpenShift. I'm just using Paas here. OpenShift is Red Hat's open source Paas platform. So I'm saying go check out the source code somewhere on a build environment, build it, and run some basic unit tests over there. So for running the unit test, it needs WildFly. So it's going to run WildFly on OpenShift for me. So the checkout, of course, happens from the Git repository. So that build happens once. Okay, that's the very important part. You are building the binary once. You are not tagging the workspace and building it again and again and again. That's no. That's a no-no. Build the binary once. That binary got to be checked into your Nexus repository. So somewhere in the Nexus or some sort of Maven repository, you push that binary. So in the process of build, you will retrieve some binaries, but your binary that needs to go through testing needs to be built once and only once. One of the common issues that I've seen is people say, oh, you know what, I've tagged the workspace and all the dependencies are pulled from there. No, doesn't matter. The binary has to be built exact one. You don't want to rip open the binary, add some artifacts, or build it again. The environments could differ. Some advocate of, build the binary once, put it in the Nexus repository, and then let it flow. So you publish the binary in a Nexus repository. Then that's where your deployment pipeline is starting. So far, you're just doing the basic work over here. Then you have a deployment pipeline, which is saying, oh, by the way, here is a sonar. I want to run static analysis over here. And what I'm giving is just one manifestation of how the deployment pipeline could possibly look. You are more than welcome to tweak it. Oh, you know what? I want sonar to be done before I push the binary. That if the sonar results are not passing, I don't want to push the binary at all. So you're always welcome to tweak it, but this is just one manifestation only. Once you do static analysis, you do functional tests, there should be a capability to run tests in parallel, that I'm going to run UAT tests and QA tests in parallel. That means they run hand in hand, because UAT could take time, QA could take time, and then once they are done, they're both done either together or at a given point of time. Finally, you say, all right, everything looks good, and this is a manual button. There's a concept of continuous delivery, which we have talked about. Continuous deployment is really the next stage where everything is 100% automated. I don't know of any organization who are doing continuous deployment. Continuous delivery, yes, a few. That means every candidate is a release, every push is a release candidate, but you're still requiring some manual process or manual step or a click which says, oh, this is good, let's promote it and make it live, sort of stuff. So here, for example, in this deployment pipeline, what I'm using is OpenShift. V2 is really, and I can use OpenShift running. OpenShift can be run in an enterprise mode, where I am running OpenShift Enterprise in my data center, where the VMs are provisioned within my data center. In the deployment pipeline that I'm going to show today, I'm using OpenShift Online. And what that means is everything is going to be provisioned on the OpenShift Online, which is a public Paas environment. The important part that I said is, it's very important that each of these stages of deployment pipeline are really pulling the binary from the Nexus repository or a single repository. They're all referring to that single source of truth. You don't want to build your binaries again and again and again. That's a no-no, again, as I said very clearly. You're using OpenShift, by all means, the process should be scalable. You can replace OpenShift with Docker containers or any containers for that sake. So that should entirely be possible. Okay, so let's take a look at it. All right, before I go here, so let me explain here. All right, so here I am. This is my, well, okay, first of all, Let's take a look at this here. Docker has this tool called as Docker Compose, which allows you, which basically used to be called as Fig, and it allows you to run a bunch of Docker containers together. The input to Docker Compose is a YAML file where you say which containers need to run. So here I'm saying I'm starting 3 containers. The first one is Sonar. There was an issue with the Sonar image, so I'm just setting restart always. Basically, every time Sonar crashes, the container is automatically restarted. This is the image that I'm using. I'm doing some port forwarding. So that's my first container. Second container is Nexus, and the third container is Jenkins. And I have some port forwarding defined over here. So when I say Docker Compose up-d, it's going to just start up those containers. And I've already pre-started those containers. So if I do Docker PS, it says my Jenkins has been running, my Nexus has been running, and Sonar has been running. It says they've been up for about 31 hours. It shows me port forwarding for each one of those. So they're all running on my local machine as Docker containers. There are 3 of those Docker containers running. So now, if I refresh this here, this is my Jenkins server here. I can have different views over here in Jenkins. If I look at a ticket monster, now ticket monster is our traditional Java EE application, which is sort of a blueprint of how do you build a Java EE application using JBoss way. So that's the application that I'm using over here. And with Jenkins, we all know Jenkins has lots of plugins, 1,000+ plugins. I don't know the number, but I think 1,000+ plugins. One of the plugins over there, and there are lots of different plugins by which you can build a deployment pipeline. So for example, there is a build pipeline here, which kind of shows picturization like this. So that's one. Or there is a delivery pipeline. That's the particular one that I like, because the delivery pipeline plugin is the one that I'm going to use today. It allows me to run the different tasks in parallel. So I could say, oh, run UAT and QA. I could define one stage, and in those 2 stages, I'm running those 2 tasks. For example, run one after the other. It allows me better categorization of tasks in that sense. Okay. So what I'm going to do here is I'm going to go to my ticket monster, and I'm going to say here in ticket monster build, I'm going to trigger a new build here. As soon as I trigger a build, and again, Jenkins is running on my local machine. There are no slaves or anything of that sort pre-configured over here. So now when I go back to my ticket monster delivery pipeline, this is the build I started this morning. But if we look at this particular build, it shows me the status of how my deployment pipeline is going through. So you can say, hey, by the way, it's running build package and code analysis cycle. I can open it in a new tab here. Here is my console output, where it's happening. Everything here is running on my local server, so the logs are very easy to tail over here. If I go back to the project here, and if I look at the configure part of the project here, now one thing to notice is here I'm running everything as a Jenkins user. Now Jenkins is the master user that has access to the entire environment of Jenkins. I can easily it allows me to do everything here, but I got lots of users here, user, tester, developer, each of which has given appropriate access, which can be really connected with your LDAP realm. Depending upon who the user is, you can configure it and say, oh, by the way, I just want to have access. You are a tester, should not be allowed to view the entire pipeline, or you can view it, but you cannot change it, or you can view it, cannot change it, but trigger a particular test cycle. So those rights can be very easily, can be very granular. So right here, for example, you can say there's a developer and a Jenkins user. What kind of rights do they have? Those can be very easily configured over here. I got some processes here. This is a fake email ID, so I won't probably get an email for this. But the configuration is pretty straightforward over here, okay? Now I go here. So that's sort of my first project here. Now if I go back to the project, and I look at my build here, and I look at the console output, if I look at the bottom here, it says, oh, sending test email to this domain. Oh, you know what? I forgot to configure my Gmail or SMTP server. So it probably won't be showing me email, but you have the full capability, and I can show you a previous snapshot. And here is a simple account that I have where I get every time a build fails or things like that. Those can be very easily configured that, oh, build failed, build succeeded, build promoted, all those different stages you can very easily configure as part of your deployment pipeline itself. So, but I have not configured my SMTP Gmail here, so that probably won't work. All right, so this one is that. Now, if I look at, say, my release here, then in the release cycle, it gives me usual Jenkins data, but I can look at the console output once again. So it talks about exactly what's happening. Okay. Well, the key part that I want to highlight here, well, that's not the fun. So the part that I want to highlight here is when I say deploy to dev. So all my basic unit tests have run, and I could configure them to run either locally or on OpenShift or whatever my Paas environment is. But if I look at my dev environment, okay, and here again, it kind of shows me the logs. It's pushing to upstream, which is basically where my OpenShift online is. So here it says deploying to OpenShift at openshift.redhat.com. And if I go to my this is my OpenShift console. Basically, it is JBoss devs, miles to go are the two domains. And I have a third domain, which if I'm going to refresh this page, it's going to show me that. So here is my user dev domain, where I said, oh, by the way, this is the WildFly or the JBoss EAP instance that it would automatically provision. How does that happen? So if I go back here, so if I look at my dev domain, I go back to the project here. I look at configure part of it. Here, I've configured that when you are deploying, this is a simple OpenShift plugin for Jenkins. All I'm saying here is I've configured two environments, online or VM. Online refers to OpenShift Online, where I've set up my credentials, and VM could refer to OpenShift Enterprise VM running on my machine. So that would work as well. You can configure multiple OpenShift environment to your internet, to your intranet, wherever it is, and use your Jenkins plugin to deploy to that particular environment very easily. So if I look back at the plugin, so now the cool thing over here is all these stages are done. Now I am as a Jenkins user, so it gives me, oh, by the way, I need to run. So this could be a setup where you could say, oh, depending upon which view you are looking at it, then you could be shown in. Like it's gone. Oh, no, it's back. All right. I don't know. It's fading in and out. Then here, if I click on run functional tests, it's going to start cycle. So the whole concept of fully automated or manual cycle that is available in this particular pipeline. So as soon as I clicked it, I don't have any functional tests, so just completed it rather quickly. But see here, now these two cycles in parallel. So you can say, you know what, both of these are going to conclude, and when they conclude that's when I'm going to go to the production cycle. And once again, I can click here and I can say, show me more details about this cycle. It goes through the entire build. It talks about what were the cycles that were run. I mean, that's the beautiful Jenkins functionality anyway. It kind of shows you the builds that have been done before this build got triggered. And here, once again, is deploying to OpenShift. So if I go back to my OpenShift console here, and if I refresh it, you can see that my QA and the UAT domains have been, or the apps have been created. You can start defining names. You don't have to create new apps every time, but you can definitely ask it to say, you know what, just delete that existing app and recreate the app. That can be very easy. That's the default behavior anyway. You can create multiple domains. You can create those different apps across different domains. So different architectures are very much possible. So it's a very extensible mechanism in that sense. So let's see, it says deploy to QA failed. So let's take a look at it. What happened there? So if I go here, if I look at console output, Yeah, for some reason, it's not able to talk to Nexus now. It did work for the other ones, and that's one of the issues that I've seen with the Nexus server. It kind of keeps going. It's a little bit inconsistent. So we talk about Docker containers. Now these are running as Docker containers, so sometimes they could be unreliable, and that's the issue that I've seen all the time over here. Now here is sending mail to this particular email account, but since the Gmail SMTP is not configured for this particular Jenkins configuration, so the email won't be seen. It'd be magic. No, it's not there. All right, so let me go back to the slides here. So what I showed you is how easy it is to get this whole build server up running. Then you can trigger a particular run by clicking on an arrow that, okay, now run my tests on a functional test. And then everything could be, UAT and QA could be done in parallel. And finally, you can say deploy to prod, which is a manual step again. You can say deploy it to a production environment. And all your tests eventually is green. So in this case, I have some manual intervention, but this could definitely be completely automated as well. And we saw, if there is a failure, that failure is indicated by red. You can click on it and dig deeper into what really happened during that cycle. All right. So in terms of references, that's where I intend to put all the content. Actually, sorry, wrong link. Let me edit it live. That workspace is not there yet, but will be there soon. We are evolving all the content over there. So everything I talked about, well, the slides would of course be available, but everything I talked about, the Docker Compose file, the Docker container, well, the Docker Compose, of course. How do you set up Jenkins, your Jenkins environment, your even your pre-configured container images. If you want to say, hey, give me a tar file for the container, I don't want to set up the container everything by myself, those would be hopefully made available over there. So I have about 4 minutes. So what I would like to do is leave you with this slide, because I think this really summarizes of what a deployment pipeline looks like. And we have 4 minutes for any questions. Well, if there are no questions, you can always find me in the hallway. Thank you so much.